Hey guys, in this video we're really looking at units and the SI system. So in this video we will be able to list the base SI units, use the appropriate SI units for defined quantities, and be able to recall the common metric prefixes used to define quantities. So when we talk about a unit of measurement, we are talking about a definite magnitude of a quantity. So defining a unit defines how much we mean. We always use units of measurements when we are expressing a physical quantity. Okay, and any matter or any property and any property of matter that is qualitative will have a unit. So qualitative associated with numbers. Okay, all measurements that are qualitatives have units. Okay. When we're taking a measurement, there are plenty of different tools that we can use in order to take measurements. If we're trying to take the temperature, for instance, we use a thermometer. If we want to determine the length of something, we would use a ruler or a metric stick. If we want to determine volume of something, we can use a graduated cylinder. If we want to determine the mass of something, we can use a balance. So generally, when you're trying to gather a measurement, you're going to have a specific tool in order to take that measurement. There are different systems of units. The one that's used in science and around most of the world is the metric system. So the metric system is a system of units. And it is a base 10 unit, which makes it very convenient. Like I said, it's used in the scientific community, along with most of the world. So most of the world will use the metric system in order to collect things. Some examples of the units include meters, liters, and grams. So meters length, liters volume, grams mass. Then we also have the English system. And this is going to be used in the US. And this is going to include things like feet, inches, and yards. Okay. Pounds are another example, all sorts of different units within the English system. We are mostly in this class going to be focusing on the metric system, though we will look at converting between the English system and the metric system. Within the metric system, we have what's called SI units, where SI units are going to be a set of units that were decided on by the French Système International des Units. So it's a set of units that were decided on by the French Système International des Units. So it's a universal metric universal metric units for defining physical quantities, specifically macroscopic physical quantities. So used universally to define macroscopic quantities or macroscopic physical quantities specifically. And then the base unit can then be used to derive other units. And those derived SI units are called derived SI units. Okay. So the units themselves can be multiplied or divided to get those derived units. Here is a list of those SI base units, so the ones that are multiplied or divided to get the derived units. For mass, we have the kilogram, and that's really the only one that's kind of weird. And it's because we're looking at more macroscopic type physical quantities, so the kilogram is used instead of just a gram. But that's the only base unit that has a prefix. So there's a prefix on that base SI unit. All the rest of them don't have one. So length would be meter, time would be seconds. Temperature is Kelvin. So Kelvin doesn't have a degrees because it is an absolute scale. And then amount of substance is the mole. Electric current and luminous intensity, the ampere and the candela, are not really used in this class, but those are the SI units and you should be aware of those. So the units themselves, as I said, with our SI units, we're looking at more macroscopic type of structures. So let's look at what other type of units we can look at. If we have macroscopic, that means we're talking about very large things, such as the size of a person. But we can have units that are described as microscopic or atomic as well. So units can be described as macroscopic, microscopic, or atomic. Okay, so if we're talking about a macroscopic unit, we're talking about a unit that's used to measure something that you can see with the naked eye. So it can be seen using the unaided or naked eye. All right, so not a microscope. These are going to be things that are 0.1 millimeters or larger. Okay. And then we have microscopic. These are going to be able to be seen using a light microscope. And they're going to be on the size range of 0.2 micrometers to 0.1 millimeters. And then lastly, we have atomic. So these cannot be seen using a light microscope. So too small for a light microscope. And these are going to be less than 0.2 micrometers in size. Okay, so these are going to include atoms, molecules, and other small particles. When we're talking about macroscopic quantities, generally we don't need to use a prefix to describe those. But when we're talking about microscopic quantities or atomic quantities units, then we usually will have to use some sort of multiplier in order to express them in a number that's not full of zeros. So measurements can be expressed as fractions or multiples of a base unit by using a set of simple prefixes. And these prefixes themselves are going to be base 10, so they're all going to be multiples of 10. The prefix precedes the base unit, and it basically tells you how you're going to treat that base unit. Are you going to multiply that base unit, or are you going to divide that base unit? Here are the different prefixes you guys should know, going from zepto up to peta. So these are the multiples of that base unit. So if we're talking about petagram, for instance, we would say that we have 1 times 10 to the 15 grams in 1 petagram. So adding that peta is multiplying that by 1 times 10 to the 15. Zepto is multiplying by 1 times 10 to the negative 21, right? So a zepto prefix indicates very, very small. A peta prefix indicates very, very large. And our break is right here. So these are smaller than the base unit. And then these are going to be larger than the base. And these should be committed to memory. Let's look at kind of individual units that are used for measuring. The first one we're going to look at is length. Length, our SI unit, is the meter. And it's a measure of how long a substance is. Okay. Mass, our SI unit here, is the kilogram. But the base metric unit is the gram. The base SI unit is the kilogram, so a little bit of confusion there. But if we're going to add a prefix within our metric prefixes, we would add it to the gram, not the kilogram, just as a note, as kilo is a metric prefix, which equals 1,000. So for every 1 kilogram, there's 1,000 grams. So this is a measure of the amount of matter. And with our mass, this is going to be independent of gravity. With our mass, this is going to be independent of gravity. Unlike weight, weight is dependent upon gravity. So we have something that is not going to be affected by gravity. Next, we're going to look at temperature. It's a measure of the hotness or coldness of an object. Okay, so when we talk about something being cold, that means it lacks heat. So we're looking at the average heat of something. Our SI unit here is the Kelvin. But very common unit that we're going to use in chemistry is degrees Celsius. Okay, And the reason that degrees Celsius is so common is because 0 degrees Celsius is our freezing point of water, and then 100 degrees Celsius is the boiling point of water. This is kind of just a comparison between Kelvin, degrees Celsius, and Fahrenheit. And you should be able to do the conversions between them. So if we want to go from degrees Celsius to degrees Fahrenheit, we would take whatever our temperature in degrees Celsius is, multiply it by 9/5, and then add 32 to it. If we want to go from degrees Fahrenheit to degrees Celsius, we take our temperature in degrees Fahrenheit minus 32, then times it by 5/9. If we want to go from degrees Celsius to Kelvin, we take our degrees Celsius and we add 273.15, and then Kelvin to degrees Celsius, we take our Kelvin value and we minus 273.15. Next unit I want to talk about is volume. Volume is a derived measurement from length. So it does not have its own associated SI unit. It has a derived SI unit. And volume is going to be length cubed. So we take our unit of length and cube it, and this gives us our derived SI unit. That's not usually the one that we use in chemistry. We usually use liters or milliliters. So some important conversions for volume are going to include 1 decimeter cubed is equal to 1 liter, and then 1 centimeter cubed is equal to 1 milliliter. Last unit we're going to look at is density. So this is the amount of mass per volume. Amount of mass per volume. You can kind of look at it like a little heart, mass per volume. And this also is not going to have its own SI unit. It's going to have a derived SI unit, but we don't usually use the derived SI unit, as the derived SI unit here would be kilograms over meters cubed, which is not a very useful unit. We generally use grams over centimeters cubed if we're talking about a solid, or grams over milliliter if we're talking about a liquid. And because 1 centimeter cubed is equal to 1 milliliter, these are equivalent to each other. Okay. Here are some densities of some selected substances. Something like air, which is a gas, is going to be very, very non-dense, while something like gold, which is a very solid metal, is going to have a very high density. And we consider that a substance that is more dense is going to have more mass in a given volume. Okay, that is it for units in the SI system. I will talk to you guys later.